Hi everyone, in today's video I will take up a question which is based on the rational horizon diagram, or what we also known as the PZX triangle, although there will be no triangle here but there will be a PZ and X. And let's understand the relationship here between the variables in a rational horizon diagram. So let's get started. So the question says that you have to draw or sketch a neat and labeled rational horizon diagram drawn to scale, and using the observer's position as 40 degrees north and 120 degrees east, and the sun's declination at meridian passage as 20 degrees north. So please read the question carefully here, because once I move the screen you will not be able to read the question again. So there are three parts to this question. So this is the first part where you have to sketch a neat and labeled rational horizon diagram to scale, of course, using the observer's position as 40 degrees north, 120 degrees east, and the sun's declination at meridian passage as 20 degrees north. The second part of the question says that from the sketch you have to determine the equation to depict the relationship between latitude, declination, and the true zenith distance, or TZD. And the third part of the question says that using the equation derived, you have to find the value of the true zenith distance, or TZD. Alright, so hopefully you have made a note of the question, or just pause the screen here and take a snapshot, so that when I start drawing the question and explaining how you will go about solving it, you don't have to reflect back on the screen here. Alright, so basically before I get started, I want you to note that here in this question the situation is that you are at meridian passage. Alright, so meridian passage is when the sun or the celestial body is on the observer's meridian, or your meridian, right? It is on your meridian. Here the meridian, of course, is 120 degrees east longitude, but this value will not play a role in today's question. It is given only for information, as we will see later on. What you have to basically note down is the latitude, which is 40 degrees north, and the declination, which is 20 degrees north. Alright, so with that, let's get started. So you have to draw a diagram to scale, of course, and I will explain the scale later on, because the scale will depend on how much page you have in your exam or your test. So basically remember that we have to draw a circle, and I think this is a good enough circle right now because it's freehand. Now of course here I am not drawing to scale, I will explain the scale later. So in these questions of rational horizon, just draw a circle and then divide the circle longitudinally, or vertically rather, into semicircles, and then horizontally again. Alright, so make sure you write north here, south here, and then west here and east here. Now this is the celestial sphere of infinite radius. So this north, south, west, east do not denote any poles, they denote direction. Alright, and now in the middle of the circle put yourself, which is Z. Z stands for observer's zenith. Alright, this is you and I am looking at you from the top. Now because you will never move, the observer or the zenith never moves, it always stays in the center of the rational horizon diagram or celestial sphere, you will draw the equinoctial, which is equal to the celestial equator, depending on whether your latitude is north or south. So here your latitude, remember, is 40 degrees north, and the declination, which can be considered the latitude of the sun, is 20 degrees north. So what you will do is that you will draw the equator or the celestial equinoctial south of the observer, putting the observer north of the equator, and you will join W to E and you will call this point Q. Q stands for celestial equator or equinoctial. Now ZQ is equal to the latitude, which is 40 degrees north. So your scale here could be, depending on how large the page is, you can take 1 centimeter, or maybe you want to take a lower scale, then you can get rid of this and you can have 1 millimeter as maybe 10 degrees of latitude. So then this distance here of latitude 40 degrees north can be 4 millimeter. If you have a larger page, you can take 1 centimeter equals 10 degrees of latitude and draw it as 4 centimeters. It's up to you. Alright, but while you draw the the latitude, now if the latitude is north, you will draw the north pole here, and this distance NP will always be equal to the latitude ZQ, which is equal to the latitude. So this should also be about 4 millimeter as per my scale of 1 millimeter equals 10 degrees of latitude. So that is the scale you have to choose. Alright, now your equinoctial, which is also north, so therefore it will go north of the equator, will be 20 degrees north, so about half of this distance here. This is called X. So you can plot the celestial body here, because remember it's the meridian passage when the celestial body is exactly on your meridian, or you can draw a parallel of latitude to the equinoctial. So this is X. The sun rises from the east and will set on the west, but right now you can say that the sun is on your meridian, the observer's meridian, and that's why I said the meridian's value doesn't play an important role, because the meridian is the line passing through Z, but it tells you basically that the sun is on your meridian. So here the P, Z, Q, X all are basically in the same meridian, or rather drawn that way. So the body is on your meridian. Now here QX is equal to declination, which is equal to 20 degrees north, and based on my scale this will be drawn as 2 millimeter. Alright, and you can draw it like a parallel to the equinoctial, to the celestial equator. Draw it like a parallel. Alright, so therefore we go to part 2 of the question, that from this sketch determine the equation to depict the relationship between latitude, declination and true zenith distance. So true zenith distance in this diagram is nothing but Zx. Zx is equal to true zenith distance, and you have to determine that. So what is the relationship here? The relationship here, and this will be part 2 of the question, is that you have to determine the relationship here. So you can say that Qx plus Xz is equal to Zq. Is that right? If you look at the diagram, Qx plus Zx is equal to Zq, or you can say that Zx plus Xq is equal to Zq, right? So remember, Zx is true zenith distance, so Zx will be equal to Zq minus Xq. So Zx is equal to Zq minus Xq. So part 3 says derive the value of the zenith distance. So Zx will be equal to Zq, which is the latitude 40 degrees, minus Xq, which is the declination, which is 20 degrees, and this is equal to 20 degrees. So latitude minus declination will give you the true zenith distance in this case, in this diagram, in this situation where the latitude is 40 degrees north and declination is 20 degrees north. So the relationship will of course change depending on the value of the latitude and the declination. It will not always be the same. That's why we have to draw this diagram. So I hope you found this question interesting and you can solve questions like that. I will take up more examples in future using different values of latitude and declination. Sometimes it will be south, sometimes it will be the equator where the observer is. Sometimes both latitude and declination will be south, or it could be one south, one north. There could be a scenario where the declination is larger than the latitude. So we'll take up those different examples and I will show you through different videos. Let me know through comments in the comment section whether you have any doubts or not. Bye.